This part of the lesson will help you review of what we've done so far with parallel and perpendicular lines, especially when it comes to identifying different angles with parallel lines and identifying the reasons for proofs as we work through these problems. So first thing is, if you take this, what I'd like you to do is when you take this sheet, it's called an exit slip for sections 3 through 5, so it's to kind of see how we're doing in these sections in chapter 3. Change this down here. It says measure of angle 7 in problem number 4. Change that to measure of angle 8. What I'd like you to try to do is try taking this like a practice quiz. Do the problems, try them out, and then what we'll do is we'll come back and we'll go over how to do these problems. So pause the video, then come back and try these with me. Now that we're back, let's go ahead and look at these. So if you take a look, here's what the answers are to this. So what angle is the alternate interior with angle 9? Well, if you look at angle 9 here, this is the angle right here. Notice it's, if you want to jump on the other side of this transversal, you go over to the other side, and interior that's not adjacent to it would be this angle 6. So 9 and 6 are alternate interior. 9 would be corresponding with angle 1. It would also be corresponding with angle 11 because you go follow this one as a transversal, and that would give you corresponding over to that side. And if you were following this transversal here, you could go all the way over to this one, and you would have angle 16 down here is an alternate exterior angle as well with that one. If we go back up to 6, 6 and 10 are on the same side of the transversal. They're interior, so 6 and 10 would be same side interior angles. So it's a quick summary of all the different angles that types we've talked about. Now, let's go back now and let's try these others. So we've taken a look at that. So what we want to do is, if we've got these as parallel lines, so both are parallel, name all the angles supplementary to angle 10. So if we start with angle 10 here, okay, supplementary, it would be angle 11 because it's same side interior angle, same side of this transversal if I follow this here. And then also would be supplementary to angle 6 if you follow this one, same side interior angles there. So we'd have 11 and 6 to start off with. Well, now we could go with all the angles that are congruent to 11 and 6 because those are same side interior. So we've got the vertical angles, 1 and 16 are vertical with 11 and 1. So we could name those, okay? So we could do 1 and 16. We could also do with these the corresponding angles to these. So if we want to go with 6, which is corresponding, that would go 14, which forms a linear pair anyway. And then also we could do the same thing over here, that 15 would be as well. So we go with, on this one, actually 10 would be supplementary to 11, and then 16 because that's the one that is vertical with number 11. So we've got 16 and 1, 14 and 9 also because notice that these two form a linear pair, and then 14 because these two form a linear pair. So we've got same side interior, linear pair, and then vertical angles that get us there as well. Now, this one here, if angle, let's go ahead and erase that a moment. So, rid of this here. Okay, now, if we have angle 13 congruent to angle 12, I'm going to just circle those two. So 13 congruent to angle 12. Okay, which lines are parallel and by what reason? Well, notice if you follow this would have to be then the transversal to get from there to there. So A and B are our two parallel lines, and notice that these are exterior to those and also on the other side of the transversal. So 13 and 12 are going to be alternate exterior angles. That leads to them being parallel. You could also use alternate exterior angle theorem as the title for that one as well. All right, here's the proof for this one. Okay, using this information up here, notice that we've got the angles 10. Let's go ahead and erase this here. Okay, so we've got angle 10 and angle 8 here. We know add up to 180. That's given to us. We want to prove that these two are parallel. Okay, so we have that M and N. These two are parallel. The horizontal ones are parallel. We'll use that. Now we want to prove that these two are going to be parallel. So don't use these as parallel lines yet. We'll just use these two. So I'll just highlight this one is parallel to this one. That's what's given to us. Okay, so there's our given. Okay, that those add up to 180. Now what we'll do is we start off by stating the given. Next, because these two lines are parallel, we know that 11 and 8 are congruent. So I'll circle that in green here. These guys are congruent because they're alternate interior angles with these two parallel lines following this transversal down. So we've got that down here. Angle 11 is congruent to angle 8 by parallel leads to alternate interior angles congruence. Now, if they're congruent, then we know that those angles are equal by definition of congruence. Then we can take these and say, okay, we want to substitute in measure of angle 8 into, take that out and put measure of angle 11 in for it in this statement. So measure of angle 10 plus the measure of angle 11 equals 180. That means 10 and 11 are supplementary. That's by definition of supplementary. So 10 and 11 supplementary. Those are same side interior angles that are supplementary. Well, because of that, we can now say that those two lines are parallel by same side interior angle supplementary leads to parallel lines. And then lastly, here's the work for doing a line perpendicular through this point. Just a reminder, if you've got this point here, you draw an arc first with your compass, then treat these two as endpoints and do perpendicular bisector by doing the two arcs here, and then draw the line that's perpendicular to the given line through that point. So these problems will help you review the basic ideas, the major ideas in sections 3 through 5 as you prepare for